And there, you lemons. We're going to do example 22 here, where we're going to be solving logarithms or logarithmic equations. So here we go. Let's do part A. We've got the equation as log base 5 of x is equal to 3. Notice my notation, I've used brackets there. And how I would solve this, I like you to understand it. It's just inverse operations. So here I want to find x. That means I need to get rid of the log base 5. Now, opposite of logarithms is exponential. In this case, it's log base 5, so then I need an exponential base 5. So on the left-hand side, I'm going to do 5, so exponential, base 5 to the power of whatever's on the left. And then I'm going to do the same thing. I'm going to do 5 to the power of whatever's on the right. This is on the right, this is on the left. So when I do 5 base exponential base 5 to both sides of the equations, this is what I'm going to get. This is still the left-hand side, so log base 5 of x, and on the right-hand side, it's 3. So you can see here that when I do the inverse 5, so exponential base 5 to the power of log base 5, these are inverses of one another, and they cancel out. Hence why I would then get just x is equal to 5 to the power of 3. Now, for some of you, this may be a bit confusing here. Why do they just cancel out? Well, the theory behind it is very straightforward in the sense that it's similar to what you normally would have done in year 7. Say if I gave you 5 times x is equal to 3, and I said solve for x, right? So if I want you to solve for x, what would you have done? You would have said to find x, you need to get rid of this 5, and you would get rid of that 5 by saying, let's divide both sides by 5. True? Well, why did you divide 5? What you did here was you're saying division is opposite of times. That's why you divide both sides by 5. Now, I haven't done anything different. The opposite of log base 5 is the inverse, which is 5 to the power of log base 5. Does that make sense? So if I go back to your calculator and show you, see if I do 5 to the power of log base of 5, they're going to cancel out. It doesn't matter what number is in here. So if I do 5 to the power of log base 5 of 3, the answer is going to be 3, because the 5 and the log 5 cancels out. And if you do the other way around, if you did log, whoops, that's not log, log base, say 7, and you did log base 7 of, now what's the inverse of log 7, right? If you did 7 to the power of, 3, see the log 7 and the exponential base 7, they're going to be inverses of one another. So they're going to cancel out. So the answer is going to be 3. Can you see that? They both cancel out because they're just like saying 3 plus 5 and the minus 5. The plus 5 and the minus 5 are inverses. So they're going to cancel out and it becomes 3. Or you can do 3 times 7. Okay. And what's the opposite of times 7? Divide 7. So if I did 3 times 7 divide 7, the times 7 and the divide 7 are going to cancel out. And it ends up being 3. Can you see the pattern? So the reason why students find this tricky is because they're used to seeing symbols. Plus 5 and minus 5 is easy to see. And times 7 and divide 7 is easy to see. But the trick with exponentials and logs is that 5, exponential base 5 and log 5, that doesn't look like operation. That's why students get confused. But technically, it is the same thing. Have a think about what I just said. Okay, now I'm going to come back here and I'm just going to solve all of these examples just so that you can see what I'm doing there. So I've cancelled that out, and then here I've got x is equal to 5 to the power of 3 is 125. Okay, so I'm going to do the same thing for b. So I've got log base 5 of 2x plus 1 is equal to 2. So I do the same thing. I'm going to do 5 to the power of the left-hand side, and I'm going to do 5 to the power of the right-hand side. So what this does, is I now essentially have 5 to the power of log base 5 of 2x plus 1 is equal to 5 to the power of 2. Okay? 5's cancel out, and then you end up with 2x plus 1 is equal to 25. And then same thing here, you would say minus 1 because that's plus 1, minus 1 on both sides. And you get what? 2x is equal to 24. And then how do you get x by itself? You would say divide by 2. Can you see I'm just doing the inverse operations for every one of them in the same way that you normally would. So x is equal to 12. See my pattern? So definitely, I hope you're watching this video because it helps you understand that logarithms and exponential is no different from what you've been doing with add, subtract, multiply, divide. Okay, so let's have a look at C. So C is the same thing. I've got log base 2 of 2x plus 1 minus log base 2 of x minus 1 is equal to 4, right? So in this case here, I will actually need to use logarithmic rules. I know that in one of my rules that if they have the same log base 2s and I'm subtracting them with no numbers at the front of them, then I can combine them together and it becomes log base 2 of 2x plus 1 divided by x minus 1. Okay? Is equal to 4. So I've just combined them. That's all I've done. And then from here, you see, I want to get rid of the log base 2. So how do I get rid of log base 2? I do 2 to the power of the left-hand side and then 2 to the power of the right-hand side. So that ends up looking something like this now. 2 to the power of log base 2 of 2x plus 1 all over x minus 1 is equal to 2 to the power of 4. We know that these are inverses of one another, so they're going to cancel out, and you are now going to have 2x plus 1 over x minus 1 is equal to 2 to the power of 4, which is 16. Okay, and then from here you can try to solve. Now, I just realized I'm running out of space, so I might try to make this a bit smaller, actually. See if I can make that a bit smaller. There we go. I'm just going to move this up a bit. Maybe I'll make this a bit smaller. And there we go. I'm just going to move this back up as well. And I'm going to make this a bit smaller. Look at that. Beauty of technology. Okay, so from here, some of you might already have troubles with fractions and solving. I would then say times both sides by x minus 1. Okay, because x minus 1 divided by x minus 1 are going to cancel out. And then if you do that, I'm just going to use red instead. So then now you're left with 2x plus 1 is equal to 16x minus 16. Okay, and then combining all the x's together, add 16 on both sides. So this now becomes 17 is equal to 16 minus 2x is 14x. So really, x is equal to 17 on 14. I hope I haven't made a mistake. That looks really good. Let me just look at the question again. 2x plus 1 over x minus 1. Correct. It's division. Yep. And it's 4. Log base 2. So 2 to the power of 4 is 16. And 2 to the power of log cancels out. 16 times x, 16x minus 16. Yeah. Plus, so 17. Yep. No, should be okay. All right. Let's have a look at D then. Let's look at D now. So D is, I can see I've got what? Log. I've got log base 3 of x minus 1 plus log base 3 of x plus 1 is equal to 1. Okay, so from here, I'm now going to use logarithmic rule number 1. I'm going to combine these two together, so simplify it to become log base 3 of x minus 1 times x plus 1. I'm going to use square brackets to show the difference between them. Okay, and here we go. Let's now try to solve this. So if I multiply those two together in the brackets, that will give me x squared. Well, that's difference of perfect squares actually. So it becomes x squared minus 1. There you go. So log base 3 of x squared minus 1 is equal to 1. And same thing again, how do you get rid of that log base 3? Do the inverse of log, which is exponential. So 3 to the power of the left and 3 to the power of the right. So I'm going to rewrite that again. That is the same thing as writing 3 to the power of log base 3 of x squared minus 1 is equal to 3 to the power of 1. We know that these are inverses, so they're going to cancel out, and you end up with x squared minus 1 is equal to 3. Add 1 on both sides, so x squared is equal to 4, and then square root both sides. Remember, when you square root, it's plus or minus answer, which is root of 4, which is 2. Okay, so therefore you get two possible answers there. I'm just double checking something here. Technically, it is meant to be plus or minus, but one property that may not have been discussed yet in class is that if you had -2 plus 1 there ends up being log 3 of, oh my god, why did that move? -2 plus 1 is -1, and you can't do log of a negative number. Okay, so therefore, I'm going to write here, therefore x is equal to 2. Okay, so I'm gonna write here as a note to remind you, note log base a of m, m is greater than 0. Okay, to be defined. I'm essentially saying that the value of m has to always be positive. It can't be a negative value. Okay, but that's how you do example 22.